let's talk about drying shrinkage, what that does. I know we've had a video on plastic shrinkage.
Yeah.
So the next iteration would obviously go to the next type, which is drying shrinkage and what that.
Yeah, great, Josh, thanks. So drying shrinkage is the next one, and drying shrinkage is a different animal. And the reason we wanted to tackle shrinkage in this way, plastic and drying, is because sometimes they're confused and people will intermix the terms, and drying shrinkage is certainly a different animal.
Remember, well, the timing comes really close together. You go from one right into the other one, and because of that, and because they do affect the amount of moisture there, it can be confusing to people.
Absolutely. So drying shrinkage happens, as we mentioned, concrete's at its greatest volume when it's first batched in place. So it gets to the job, it's placed, and then it begins to lose water. And it loses water through bleed water channels, capillary void structure, that bleeding occurs, and then evaporable water starts leaving the system. Well, think about it like this. Have you ever seen a dry creek bed or a dry mud hole? You see how it used to be wet, but then it dried out, and now you have a lot of cracks in the bottom of the mud hole or the bottom of the creek bed. A similar action is happening with concrete. As water is leaving, then that concrete wants to shrink. Now, if we poured concrete in a vacuum in outer space, then it would never have drying shrinkage cracking because it would not be restrained. So when the concrete goes to shrink and it's restrained by either the ground, blockouts, reentrant corners, plumbing, you name it, then when that tensile stress that develops as it's shrinking and it can't move is greater than the concrete can resist, then that's when you have cracks occur. And that's why we cut control joints, or what are more accurately called contraction joints. Those contraction joints are cut to give the concrete a place to relieve itself from that tensile stress.
And if you don't get them fast enough, then you get uncontrolled cracking that no one really wants.
Or if you don't get them deep enough. If you know, the joints need to be at least a quarter of the depth of the slab, and if they're not deep enough, then they may not function properly. So drying shrinkage is commonly referred to as a leading cause, and some people will say the #1 cause of cracking in concrete. So nobody's ever going to tell you that they'll guarantee zero cracks in concrete, but if you can understand drying shrinkage and understand how to control it, you can greatly improve your chances of having a pretty concrete job. If we can help you in any way learn more about concrete, or if we can help you with a particular project, let us know. We're happy to, we love concrete, and we're happy to help any way we can.